All right, so before we get into sine and cosine graphs, I know you guys already took the notes, but I gave you guys like a little Easter egg on 6.1. Um, so if you watch 6.1, you saw a little Easter, I gave a little Easter egg out there, a little bonus problem, right? So I kind of want to go over that real quick. Um, but I do need you guys to do some things. But before we go over those things, um, for sure I need you guys to hopefully you're on a computer because it work better off a computer. I need you to go to desmos.com, okay? And we're gonna type in the two functions we're gonna study today, which is sine of x and cosine of x. Now, when you type it in, it's gonna look something like this, right? You just go ahead and click this the little icon on the side, and it kind of turns them off. I don't want to look at this just yet, but I do want you to have this window open. We're gonna come back to it. Okay. So is it this one? No, it's not this one. Okay. This one. Okay. So here's a little hint on the Easter egg. So we were talking about degree measures and we're talking about radians. And we found out that this first one was, if I could make it move, was 30 degrees. Oh my goodness. 30 degrees, which was actually pi over 6, right? In radians, pi 6 radians, right? And 30 degrees. And I asked you what would be the coordinate, right? And what I was hoping you guys would click on was that the 30 degrees should trigger something in your head. Be like, oh, it's a 30, 60. This right here, this angle would be 60, and this is a 90 triangle. So that means this side right here and this side and this what would make the special right triangle. So we have x, we have 2x, and we have x square root of 3. Okay? So that means we know that this was all based off one unit. We talked about that. I said it several times. It was one unit in radius. So that means this would be um, our r actually would be 1, right? Because this is our radius, which would be 1. And we know that the short side is 2 times this. Well, I mean, sorry, the hypotenuse is 2 times the short side. So that means we go 1, cut it in half. So the y is 1 half. And then this would be 1 half times square root of 3. So square root of 3 over 2. So our x is square root of 3 over 2. Our y is 1 half. Okay. So I was hoping you guys would remember the special right triangles that we did. And if you go to the next one, oops, let me see if I can get it. It was a 45, 45, 90, meaning this angle's 45, this angle's 45, right? We still know that the radius is 1, so the hypotenuse is 1, right? But to get the hypotenuse, right, we would do x times square root of 2. But now we're working backwards. We're doing something backwards. And I wish I could write on this, but or maybe I could let me see if I can do something real quick. Yeah, I can. Let me see if I can do something real quick. Move this to the side. Move this to the side right here. So, so when we have this right here, so we have this triangle be over here. Okay. And we know that we know that this is 1, and this would have been equivalent to x square root of 2, right? So if we want to solve for x, We just divide by square root of 2. So we have 1 over square root of 2. But remember, we don't like to see this. We don't like to see the square root of 2 on the bottom. So we multiply the top and the bottom by square root of 2. And we get square root of 2 over 2. Right? And because they're the same angle here and here, that means they have the same angle sides here and here. So that means if this is square root of 2 over 2, then this is also square root of 2 over 2. So the coordinates would be square root of 2 over 2, square root of 2 over 2. Now that's all the hints I'm going to give you, right? That's all the hints I'm going to give you. But you should pretty much get it from there. You should be able to get all the coordinates all the way around, which is what I was asking from you for your bonus, okay? Now, if you find this applet on GeoGebra, well, then you're going to get them all for free, right? Or you can Google them and you can get them all for free as well. But the point is for you to kind of explore and figure it out. Um, I was hoping you guys would do it like this mathematically, but I mean, if you use the internet, that's fine. Um, it's a good tool, right? The internet is a great tool, and I really like this. So I'll give you guys one more. And you should actually see a pattern happening. And we'll probably discuss this in our class session. The pattern that happens from here. Notice square root of 3 over 2 and 1/2. And then we go right here. Whoops. Where is it? Square root of 2 over 2 and square root of 2 over 2. And then this one, you can see something. Oh, man. I wish this was a lot easier to mess with. Okay, so I'm just going to. No, I'm not going to show them all. No. So this would be 1/2. Ah, no. The cat is out of the bag. There's a lag. That's why. Okay. Okay. Yeah, there's a lag because I guess because I'm recording. So it'd be 1/2, and then square root of 3 over 2. And so it goes all the way around, guys. And these are important because um, you got to know positioning as far as on the unit circle. And the more position you know, the better knowing this is going to make sense. So most people will tell you, bam, here's the sine graph. Learn it. Starts at 0. It's got an amplitude of 1, and then it's got a period of 2 pi, right? And you're just like, okay, what? And then they're like, okay, learn this one too. Here's cosine. It starts at 0, 1, and it's got a period of 2 pi, and so on and so forth, right? But it's this connection between this graph right here. I want you to see this graph. See how it flows. It starts at 0, 0, and goes up. And it really connects to this unit circle. So I want you to see the unit circle side by side with the graph. So when the sine is 0, the graph is 0. But as we increase to, let's say, 30, whoa, that was too much. 30 degrees, our graph's increasing. Okay, we go up to 90 degrees, and we kind of reach our apex. Right? We reach the highest point, which the radius is 1. Okay, our radius is 1. So that's key right there. This is key. This 1 is key, right? We keep on going. Whoops, sorry. We keep on going. And look, at 180, it zeroes out again. Ugh. Uh, well, it zeroes out again. It hits the 0, right? And we can continue it all the way down. And at 270, it's -1. And that's also key. Okay. So, and we go all the way to 360, right? And where it zeroes out again. All right. So this is key, guys. This is the flow of the sine functions. Starts at zero. So a sine of 90, it's always going to equal to 1. A sine of 270, it's always going to equal to negative 1. A sine of 180, 0, right? And so on and so forth, okay? And these are important. This is important to kind of understand because when we're trying to find uh you know sine of 219 and we're trying to graph it, or we have to shift it or move it, it makes a big difference, guys. It makes a big difference knowing where should we be looking, and why are we moving it this way, and what would happen if we do that. Okay, so I want you guys. I'm gonna put this applet with the notes and this video, so you guys could play around with it. This is a very good applet. Um, I really really enjoyed it. I found it on the internet. I found it on GeoGebra. I use this website quite a bit for my geometry classes, and I felt like this was a good applet to show you guys. So our key points. I'm gonna go back to decimals for my key points. So here's my key points right here: 0, 0, pi over 2, and 1. Okay. So right here we're doing it in terms of right here we did it in terms of degrees, right? So right here it was 90 degrees. But we know what 90 degrees is in radians. It's actually over 2, right? We learned that, right? We know that they coincide. Um, so oops. So if we continue, moving this, right, and graphing this, we could actually figure out where each point is, right? Pi. These are the important points to note. Now, why are these the important points to know? Is because whenever you're graphing them, you're going to get problems that say shift it up 4 units. So you have to figure out, well, what changes? Change? Does the y change? Shift it right, shift it left, stretch it. The period goes from 2 pi to 1/2 pi. So that means this will compress, this whole graph will compress, right? So we need to know these things. But first, I want you guys to know the basics, right? Know what the parent function looks like. And this is the parent function of sine of x, right? And cosine of x looks very similar. That's why we study them at the same time. Because cosine and sine look very similar. Little bit of tweaks. And I'm going to show you them both at the same time. And then I'll take away the sine x graph. So look, cosine x looks, the wavelength looks almost identical. But now, look at the difference. Look at the difference at points. So I'm going to take away the sine graph. Now, cosine starts at 1, 0, 1. When it's pi over 2, what is this pi over 2? What degrees is that? Okay. When it's pi, it's at negative 1. What degrees is that? 3 pi over 2, what degree is that? These are the questions that we should start asking ourselves, right? So when we graph from our unit circle, we can actually see it. So, ooh, it already had started. So we start at 0, 1, right? So our graph's at 1. When we go to 90, look at 90. Oops. 90 is 0 right here. It's flat. Just like how we saw it right here. Pi over 2 was 90, 0. So what about 180? What happens at 180? At 180 degrees, it's negative 1. Look at our graph. Pi, 180 degrees, negative 1. So what would 3 pi over 2 be? It would be the next time is at 0. or I could get it on the money. Close. Right there. 0, 270 degrees, and that's when it's 0. And then, of course, 360, it returns back to 1. So a full cycle would be from, if it starts at 1, dips all the way down, and comes back to 1. When it does a full cycle like that, that is known as a period. So a lot of kids will get confused with this. They think it starts at 1, goes to -1, they think that's the period. No, no, no. The period is where whatever number it starts at, it has to come back to that number. So it goes down to -1 and then comes back to -1. So this would be one full cycle or one full period. Same thing here. So if you notice, uh, here it starts at 0, goes all the way up, goes all the way down, and then it ends. And notice we don't count this from here to here as a as a as a period, even though it's 0, 0, because it still is going down. It still has this negative part that we have to continue with. Okay, so that's the difference between the sine and the cosine. They're not very much different. They look very similar. A lot of people will give you a sine function and ask you to convert it to a cosine function, and we did that before, right? We did the, what was it called, the co-functions conversions, where I gave you a sine function and you had to find like the complementary co-function of it, and it's because they're very similar. So let's go to our notes. So um, most of the time you don't see sine in this form right here. This is the kind of like a general form of the way I like to teach it, so you guys can kind of get a full kind of concept or understanding of the concepts, right? Usually, you just see y equals sine of x, or y equals sine 2x, or y equals 4 sine x plus 10, right? And and they go from there, right? So, but what I like to do is I like to go over these concepts right here. So, maybe I should zoom in. It's a little small. Okay, so again, keep decimals open because we'll be going back and forth. So the a, so the front number in front of the sign. So like in this case, it would be this one right here. That would be our amplitude. So amplitude. Sorry, I keep saying that word wrong. So let's say you choose a different color. Choose red. Red. So I had this graph like this. Okay. So the amplitude would be the highest point and the lowest point. So I want to know the difference. So in this case, my highest point is 1. My lowest point is 1. So to find the difference, I would go 1 minus 1, which gives me 2. And then I always cut that in half. Boom. So in this case, my amplitude is 1. That would be my general case, right? Now, if I had 4, I'm actually stretching it, right? I would be stretching it a little higher, a little lower. So let's say this was 4 and this was 4. It'd be 4, sorry, -4. So it'd be 4 minus 4, which would be 8 divided by 2, which my amplitude is 4, and my front number is 4. That's how you calculate it. And the only reason you're probably thinking, sir, well, why don't we just use that number and that's our amplitude? Yes, generally that's what you do. But sometimes you actually do need to know this because they won't give you the full, they probably won't even give you this. They probably won't give you the equation. They'll ask you to build the equation off the graph. So they'll give you a graph and they'll tell you that this is 2, right? Or this is pi over 3, right? So, and then you have to kind of build and start going from there. So it's good to know, right? So our lead number, our lead coefficient would be our amplitude, which is our a, okay? And it's always half of the distance between the maximum and the minimum point or the values. Okay. Now we're gonna have this number on the inside. Okay, this number on the inside is super important. It's probably the most important point, the most important um, number in all of the sine uh, coefficients, the A, the B, the H, the K. It's probably the most important one because that tells us the period, right? It's the interval of the length. So it's the interval of this right here. Okay, well, not necessarily B itself, but B is a big part of it, right? So the period will always be 2 pi divided by this number. Okay. Okay. It's always going to be 2 pi divided by that number. So when they ask you, what is the period? Right. Okay. So in this case, we have a one, right? We have a one right there. So this one would be 2 pi divided by one. Right. So this one, the period is just pi. Okay. But this one's going to be different because we got a 2 right here. So we would go 2 pi divided by 2. And in this case, our period is pi. And it makes a difference. Okay. Now, there's going to be times where they try to trick you, where they're going to give it to you something like this. They'll give you y equals sine parentheses. They won't put nothing here, and they'll put 1/2 x minus 1/2. Right? They'll do something like that because that goes into what we're going to go get into in the next part. But you have to be cognizant of this that you could actually factor out a 1/2. So this is actually sine of 1/2 x minus 1. See that? So this is our b. See right here, you're thinking the b is there's nothing, right? There's no number here. So you might even think it's 1, but it's not. It's actually 1/2. So you have to be careful with that. Sometimes they give you these tricky ones. Okay. I'm not going to give you these tricky ones right now, but later on I might. Okay. So just be cognizant of that. So this is probably the most important one. The H, you would always have parentheses. If you don't have parentheses, we're going to have a problem, right? We're going to get confused. But you'll always have parentheses. And the H is just kind of like any other vertex form that we've worked with in algebra 2 and geometry, right? It's a left and right shift, right? So if the inside, um, if you see a -5, that means we're going to be moving to the right. If you see a +5, then moving to the left, right? If you see it. I'm not saying that is what H equals. I'm saying if you see it in terms of the the equation. So you should already automatically know if you see -1, boom, we're moving to the right. Okay. But that's not what H equals. H will always equal the opposite of that. So H will be +1. So just kind of remember that. And then the last number by itself is always your vertical shift. It's always the y-intercept, right? You go moving up and down or whatever. So, like I was saying, so the vertical shift, right? Um, so right here on this vertical shift, sometimes I mean, most of the kids understand that it's an up and down movement, right? Plus means up, minus means down. And then, so we're so used to seeing it like this. We're so used to seeing it at the end, right? Plus 10, right? So we know that's our up movement, right? But sometimes they'll try to trick you and they'll write it like this. So they bring the 10 to the front. Okay. You're still adding it. So this is like your vertical shift. So be careful with that. Be cognizant of that. That's going to come up. That's gonna play a big part. It's and I don't know on the homeworks if I do that, but I know for sure on the test I'm doing this. Okay. So now the same concepts of the A, the B, the H, the K apply to cosine. Okay. The cosine is just the graph starts at a different point, right? So, but the A, the amplitude's same concept, period, same concept, shifting left and right, same concept, vertical shift, same concept. So, here's where we're going to use Desmos. Okay. So I'm not going to draw any of this on the handout, because I want you guys to kind of have decimals out. So I'm going to try to get my screen to split a little bit better. There he goes. There he goes. So what do we have here? Gee Willikers. Okay, I can now see it a little bit. Okay, right there. So I'm going to erase this one. I have sine. Okay, so I want you to sketch this graph right here. So you'll be sketching it here. And then I want you to compare it to sine of 1/3 x. So you would come here and you would type in sine of 1/3 x. Ooh, look at that. Let me close that so you can kind of see it. Maybe I can zoom out. And now I want you to compare this green and red. So in fact, let's do it like that too. Do the regular sine, sine of x, will all be in red. So each one of these will be in red. And then your new graph, your new function will be in green. Okay? So notice we have the 1/3 x. So remember, what does that 1/3 do? That 1/3 changes the period. So now what that means is our period, the time it takes us to do one full cycle, is no longer 2 pi. So remember, in the parent function, it's 2 pi. So to go from here all the way to here is 2 pi. But that's no longer the case. It's actually 1/3. We're gonna go 2 pi, and then we're gonna go 2 pi divided by 1/3, or you could say 2 pi divided by 0.3333, and it actually extends it 6 pi. So if we come all the way over here, so 6 pi would be 6 times 3.14, so roughly about 20, no, like 18 maybe. So we're gonna go all the way up, all the way down, and right there. No, 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 actually all the way up, all the way up. No, 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 down. I was right, down, because it's 0, and then right here, 6 pi. There it is, 6 pi. So because we did 2 pi divided by 1/3, it's like that keep change flip. So it's 2 pi times 3. So it essentially becomes 6 pi. So our period becomes way longer, right? So that's kind of what I wanted you to see. Now, so this is what you're sketching here. Okay. So a good thing to type, to make sure you label, are the start points and the end points. Okay. And then on the red graph, start point, and then the end point would be right here, 2 pi. Okay. So you could put 2 pi right here, then 6 pi over here. So now, what if the 1/3 was not on the x, but it was in the front of sine? So how does that make it a difference? Okay. Now we're gonna have 1 divided by 3 sine of x. Okay. And what does that do? So let's kind of zoom in a little bit. Where is it? Where is it? There it is. So what does that do? Does the period change? Nope. They're both at 2 pi. They both start at 0, 0. But what changes? What was this front number? What does that do? Well, that front number was our amplitude. Remember how high it goes, how low it goes. So now it's 1/3. So it's kind of like shorter now, right? We're compressing it as well. So I want you to again graph these to the best of your abilities. You're doing a nice little sketch, right? You're doing a sketch. I want you to start learning how to play with decimals, because It's a tool for you guys. It's going to help you. It's hard to see these graphs on your calculator. It's really, really hard. The screen is very small. Here on the computer, you have the option of zooming in. You can find your key points right away. Um, so I want you guys to get familiar with decimals. And if you want to make an account as well. So let's go to the next one, sine of x and negative 2 sine x. What happens when we have a negative now? So let's see. Let's see what happens. Negative 2 sine x. So what happens? Notice the first one goes up positively, then comes down, and then goes into the negative side. Because we have a negative, it's now going to go down negative first, and then it goes up. And notice it stretched two, right? Because our amplitude is now bigger as well. It's a two, it's bigger than one, right? So it's kind of like the parabolas when we open them and we close them and we stretch them and we compress them, right? Those rules kind of still apply here, right? So, oh, and kind of like the reflection and whatnot. So this is kind of like a reflection, right? So this is like it's pointing down, like if we were to look at this part right here as like a parabola, a negative would flip it, right? So, so similar concepts, right? We've studied these ideas before, but now we're just applying them to our trig functions. We're tweaking them a little bit. We're tweaking them a little bit. So again, I want you guys to write down the key points, some key points of these graphs, right? Um, on your test and on your homework, you might get a graph like this, right? You'll get the parent function, and I might just ask you, where do they intersect? Or compare the amplitude of the parent function to the amplitude of the second function. What is the difference? Okay, what is the change? Okay, so I wanted you guys to kind of see that we are going to do problems like this, and I want you to get used to using decimals. All right. What's the next thing on the list? Oh, right here. Here, we should be good enough and solid enough to be able to write down what's happening. Okay. Me personally, um, I already color coded it for you guys. So um, I'm gonna do like the first one and maybe the second one, and then I'll let you do number three and number four. So what is the A? Well, the A is -2, and what does that do? Well, we know we talked about it. It reflects. It it reflects, right? It starts by going into the negative side instead of the positive side, but it also stretches it, right? We've noticed that it's stretched to an amplitude of 2 instead of just being at 1. Okay. Now, what is this 3 gonna do? Well, this 3, so let me get the green. This 3, what is it gonna do? Well, we know we're gonna have the period is gonna be 2 pi over this 3. So, well, 2 pi over 3, what is that going to do? Well, that's going to compress the period, right? Because it's going to make 2 pi is roughly, I don't know, 6.28 is what we said. So now we're going to have 2/3 of a pi, right? 2 pi divided by 3. So we're taking this 6.28 and we're dividing by 3. So we're getting what? 2 point, what? 8, 9, 9 roughly, 2.9. So we're kind of shrinking it. So that means we are compress the period. So now we want to look at this x minus 9. And we know that as soon as we see the -9, we're going to move to the right. So we're going to say uh, moves 9 units right. And we know, oh, should be blue. Uh, blue, okay. So don't mind this one. And this -2 means that we're going to move it 2 units down. So essentially, guys, these are the two numbers I like to start off with because I know that those either move right or left, up and down. So like right here, I see a +2. So that means I'm going to move up 2 units. Let's see if I can get this red going. Um, and so this H, do I have an H? So I would put no movement, right? Sometimes you have that. What about the 1/4? This 1/4 for the B, right? What does that do? Well, again, I'm going to say 2 pi divided by 1/4. Or I could say 2 pi divided by 0.25. Or in essence, if we do that keep change flip, it's like saying 2 pi, actually, it would just be 2 pi times 4, right? So in this case, this period becomes 8, uh, becomes 8 pi. So it actually extends it. Oh man, why is it not clicking the green? Okay, so hold on. I'm having a little issue here. Okay, there we go. So 8 pi, which means it extends the period. So there we go. Um, Next one. The amplitude is purple. So it's 3. So that means it's going to stretch it. It's going to make it bigger. So we know that it's going to go all the way up to 3, come all the way down to -3. So it stretches to be bigger. So what I want you guys to do is I want you guys to do number 3 and number 4. I think that's the last bit of notes. Yep, that's the last bit of notes. And come come ready for class. We're going to discuss these concepts. Okay. So see you in class.